Good morning, everybody. Welcome to this month's microview webinar today. I got a lot of topics to cover today. It's good to see a lot of you joining. I will say right off the bat that this morning our internet went down in our facility, so I'm currently on a Verizon jetpack right now. So if we lose you, I apologize. And we'll either reschedule or I'll record this on my own and send it out to everybody. So I apologize if there is any technical difficulties today, but hopefully we won't have that problem. So this month, we're going to be covering a bunch of topics today that hopefully will benefit all of you, but a couple things up front that I want to tell you about. We've started adding all these webinar recordings to a YouTube channel, and we hopefully grow this YouTube channel to other topics like gauge verification, hand gauge training, blueprint topics. So we are open to any subject that would make your guys' inspection team, quality team better. And if we can provide you with continuous education, that's what Dan and I are here for, and the rest of the team here at ATI. So feel free to search ATI Metrology Training Channel, that is a mouthful, on YouTube, and subscribe to that. I have all the webinars on there and a couple other tutorials, but basically it's coming soon. It's still under construction. And but yeah, we're open to any topics there. So I always talk about the chat on this. On these webinars, feel free to pop some suggestions in there of some YouTube videos that you guys would like tutorials on, anything quality-wise. Last week, we hosted a metrology training seminar. It's a 4-day training seminar. We hosted this one at our Warsaw facility. So right down the street from downtown Warsaw, we have a new physical location down there with a showroom, calibration lab, and a training center that you guys see here. So we finished the training center up a couple weeks ago, and we hosted our first training seminar here. We bring these training seminars to different cities throughout the United States. It was nice to have it at our home base, but if you guys are interested in having this close to you, let us know, and hopefully we can bring it to you soon. Some upcoming events that we have going on. August webinar, you guys can sign up now. After this webinar, you will get that follow-up email from me with a survey telling me how this webinar helped you guys or how we can improve these webinars, and then also a link to the August webinar there. Quality show is coming up in October in Rosemont, Illinois, and we should have registrations available for that soon. And you'll be able to find that through atiquality.com/events, or I'm sure you'll be seeing an email hit your inbox within the next month or so on that registration. And what we're looking to bring around the time of Quality Show while that's going on is a best of the ATI Metrology Training Seminar. So we're looking to condense our 4 full days into 2-hour sessions of the highlights and the most critical information to help your team. So this is good for a few different people, good for brand new techs that you guys have, brand new employees that are new to the quality and manufacturing, just to give them a quick download of hand gauge training, blueprint reading, and any of you that have new employees to the microview, we're going to be talking about the importance of programming and the systems for that programming. And so it's going to be a best of the metrology training seminar. So registrations will be available for that shortly. And then we're looking to bring the training seminar somewhere around Chicagoland, because I have it in Milwaukee, I have it in Warsaw, St. Louis, and I know we've got a lot of requests for it to be local here, so not so much travel. So you guys will be hearing all about that shortly. May webinar, I want to do a little review. We do this every webinar. If you are unable to attend any of the webinars, I do record them, and a lot of you do request the recordings from me. Please still register for the webinar so you get the opportunity to get the recording there. But we talked about a few things. We talked about the camera window and things to keep in mind that At a low magnification in your camera window, you're seeing about 11 millimeters at a low magnification. Mid magnification, we're seeing about 2 millimeters. And then when you're at the fullest mechanical zoom on your microview, you're seeing about 1 millimeter. So keep this in mind when we're using our Fscan tools and programming how much of the part you actually can see in the camera window. Cool thing is the Generation 3 machine that came out last October has a little larger field of view on there. The camera is about 4 times better than the first and second gen, so we're getting some camera upgrades with the new generation machine, which is really cool. Another thing we talked about was using the rotate function. A little tip and trick that I do is I always start my rotation at 6 o'clock or at 3 o'clock, or just so when you rotate it, your tools are not too large when you see it over here on the left side bottom of this here. Because if you make your large, because the camera window is wider than it is taller, if you make your tool to fit the whole field of view, when you rotate it and it hits 9 o'clock or 3 o'clock, it's too large. And then we also talked about true position and the importance of setting up your system in Inspec to reflect your datums. And we also talked about how concentricity is off the new standard, and it's basically replaced with true position. So I've gotten a few phone calls of there's a true position of 2 diameters on top of each other, but there's no basics on the print. That'll be 0, 0 will be your basics. It's just a little thing that you're sometimes not used to seeing. You're looking for your basics. I do that all the time, that I got my blinders on when I'm looking at a blueprint and I can't find something, I can't think of something. So I go to Dan or Zachary or one of our other techs and just ask them to take a look at it, which you're always welcome to email Dan and myself for any help, support that you might need with blueprint reading, kind of interpreting it, seeing what the engineer was trying to do, or if there's something missing on the print, we're here to help you guys out. And the last thing we talked about in the May webinar was importing DXF files and how we're able to actually have an offline version of Inspec that you're able to purchase, so you can program off of DXFs anywhere that you have a computer and you can plug that dongle into. A lot of people ask me if there's a demo version of Inspec. Anybody can download the software off of Microview's website, but you need that dongle to enable it to be able to use measurements and program offline on that. Here's just a couple other lists of things that we covered. Auto generate drive points, some features and tools you might not be using. So if you did miss the May webinar, these are the topics. Feel free when you get my follow-up email today to request the recordings. Today's topics, we're going to talk about part separator. This is good for if you're translating your program to measure multiple parts across the stage. A bunch of different topics on flatness. I had Dan actually suggested, we've been seeing on prints a lot where you have an overall flatness, but then you also have 10 sections of flatness that are controlled at a different tolerance on the same surface. So we're going to talk about that. We're going to talk a lot about exporting point cloud data and what we can do with point clouds, how powerful they can be, how we can use them for R&D, and also if you have a CMM software that's able to pull in raw data off an Excel sheet, we can do surface profile a little easier on that software, exporting the data on there. MMC and LMC with bonus tolerance. A couple tricks with calculators, so we're going to get into the calculator function today. Splines. A lot of you, when Dan and I are at training, or you guys find the spline function, it's really cool because it scans the whole outside of the part, and you don't measure your whole part, but you have all this raw data. I'm going to show you some tips and tricks that I do use splines. But one thing that we always say is that when you use a spline around the outside of your part, it's really not measuring anything. So you got to be careful with it a little bit, but we'll get into that. And then max and min data. So if you needed the max height and minimum, depth on a plane, or if you're looking for multiple diameters, max and min, maybe average on a bunch of diameters, we're going to use the calculator function for that as well today. So using part separator function, here's our beginner level tip, is if you are just getting in, and this could be a tip for anybody, if you're programming, like I said, multiple parts across the stage, this helps you keep your data organized while measuring multiple parts. It also helps with SBC software, so if you have data collection software that your MicroView is exporting to, it helps separate all your parts. So if you're doing any CPKs or anything that, or run real-time data, this might help you. It also helps you keep track of your features list. So when you translate your part multiple times across the stage, MicroView technically is seeing that as one program and one part, unless we tell it, here's one part, here's one part, here's one part. So if we measure 10 parts across the stage and don't use part separator and export the data, you're going to have the 10 parts of data between your begin and end on there. And then also when you're programming and you translate the data, translate the features, when you're scrolling through the features list, it's kind of hard to see where one part begins and one part ends on there. So I'll show you here in a second the part separator function. This is one of those things where it's nice to know the tools in your toolbox, and you might never use it or you might use it all the time. But it's nice to know where it's at, how it works, so if the application does come up for you, it's available. And also it's easier copying and pasting from Excel sheets, and we'll be able to export a little bit of data today, kind of show you that function. So let's go over to Inspec here. So I got this part here with a bunch of different diameters. I'm going to treat each one of these honeycomb looking features as a different part, just for this example. But when I go and I'm going to do a recall refsys to make my program fully automated, and I'm going to go over here and I'm going to measure just a bunch of diameters. I'm going to use the profile circle tool just for ease. Sometimes the profile circle tool, the reason I wanted to use this to show you, sometimes it's not repeatable. If it sees other diameters in that profile circle, it might grab whichever one it wants. Or if it sees too much flash or burrs, it might not be able to measure it. So because that's not being nice at all, I'm going to go ahead and we're just going to go to the old Fscan circle. All right, so we got one. So now say this is my whole part, my whole program. I think a lot of us wish this was the easiest, or all of our inspection was this easy, of just doing these, 6 to 7 diameters that we're going to get here. When I get done with one program and I rename everything, I'm going to go ahead and rename these. Mention 1, mention 2, mention 3. I'm going to show you another reason why I like part separator, because even though Dan and I have programmed countless number of parts, when I translate, I sometimes forget. When you translate, you can have an option of a pending copy number to feature names. You can do that or not. And if you translate your program and you mess up on a couple things and go back, you end up starting to get a lot of underscores. So it'd be dimension 1, underscore 1, underscore 2. And if you mess up and delete, sometimes you end up having a lot of underscore additions to your names on there. So I like the part separator because if I end up doing that, it helps me out, keep track of where I was and how I can correct things. But I'm going to go ahead and do this part separator. I'm going to highlight all my circles. I'm going to do my exports. Let's just go ahead and do diameter. Let's give it some more information. And then now if I come over and I'm going to measure this part, I'm going to add in another part separator, and I'll do this last one over here. Some of you might be thinking I didn't export the second part, but since we're going to group export all these features, since they're all circles and I want all the same thing exported, diameter, close, so now I got all those exports there. And you don't have to do one at the end, but I'm going to do one at the end here. And then now I'm going to come to File. I'm going to do a manual export. And go to my desktop. .xls, so we don't end up with a text file. I'm going to do tab new line, new line. I like tab new line because all my data ends up being in one column, so I can copy and paste over to my Excel sheet that has our inspection sheet. I'm going to do tab new line, then I'm also going to show you comma, that a lot of SBC software and CPK, and depending on how your inspection report looks, might be a better option for you. I'm going to click OK, and since this is a manual export, as soon as I click OK, it exports to my desktop. And see how all the circles are together and we can't tell where one starts and one doesn't? That is because if we come over and exit out, don't save because we don't want a new one. Let's go ahead and rerun this guy. And this time, oh, Dan just told me to move a little bit slower because the jetpack is lagging a little bit here. So sorry about that, guys. Now I'm going to do comma, append to existing file. Go back to the desktop. Go down and find. So here we have all of our sample 1, sample 2, and sample 3. So this is where it's really helpful for the part separator to do comma, and then you get all your data here, and we need to expand some of these guys. And this is what a lot of your SBC software will like to see, but also any SBC software that you do have, there's probably help. So we distribute ProLink. So if you use ProLink, we're able to help you and connect you with those guys, and they'll be able to tell you what form you need all this in. But this is where I'd look at this row and have all this information. It probably wouldn't like the double quotes going on, but this is where it's able to do all one. Now, if we didn't use the part separator, we would end up having all those 3 different samples in one row. So you would have all the data in one row and it wouldn't separate it into 3 different rows here. So it could get really confusing and you could have a really long Excel file going on over there. Again, just a little tool in your toolbox that might be helpful. You know, if you could use it, great. If it's something that you're not going to use, totally fine. And these little things, usually these topics come up with a customer coming and asking, hey, I'm trying to do this. What's the solution here? which is actually a lot of the topics that we have going on here, which is when we get to exporting point cloud data for R&D. That actually came out last week at the training seminar and this week of trying to figure these things out. So feel free to shoot us messages to be able to talk about these things and find you a solution that we might be able to pull some cool tips like tricks out of calculator function and other functions that you might not use every day. So let's talk about flatness. So if we go back, I want to show you the example of what would be on a blueprint. So if we have this print right here, that we have flatness of the whole surface as a 0.3 tolerance going on. But then connected to that, underneath that is a box that says 0.1 with 10 sections. So you can see my example here, and we'll do it live in a second, is that it's looking for the overall flatness of the whole part, but then also it's looking for individual sections to make sure that that's controlled across the board. So I'm going to use the translate function on this part that I have to be able to program faster and also set my tolerance once instead of trying to tolerance and export 10 planes going on. And another thing too is a lot of the times when I'm doing inspection, I'll think, all right, I got to get flatness of the whole surface, and then I'll go back and get the 10 samples. I'm actually going to get the 10 samples first, because if we do plane more inputs, we can select all these planes and make one plane out of all of it. So that's a little quicker programming going on there. So I'm going to move over to this part that I got. Get that guy in focus. This is actually the part I was looking for. Get that guy in focus. I'm going to do line, more inputs, Fscan line to get my program up and running. I'm actually going to do a recall refsys first, so it's fully automated. Line, more inputs. I'm going to use the Fscan line. Down to the edge. I'm going to measure this line down here. I want you guys to pay attention that it's taken me, what, a little bit of time to come measure these lines. I'm trying to find my way around the part. When we talk about splines, I'll show you how it's a little easier to find your way around the part using splines. I'll turn my surface lights on. Remember, anything that we do in Z, we want to go to a higher magnification. We gain a little accuracy in Z. Anytime that I have a light plastic part, or even really any surface finish, I always check out, see what axial light looks like compared to surface light. Because remember, the camera is looking for contrast between light and dark. And so the better contrast and less gray value that we have, the better our camera can be able to focus in on surfaces. So right here, using just the surface light, there's a lot of gray value going on. So I like to look over and see if there's any better with axial light, which we're seeing a little better contrast between light and dark. I'm going to do focus point. Focus on there. We might switch back over to profile light or surface light. See how that looks. How quick that focus point takes the surface. We might have luck with the axial light there. So now I'm going to do my origin of X and Y. So remember, a solid system has three things: origin at X and Y, origin at Z to the focus point, and a skew to your longest line. So now I'm going to move up to this corner here. I'm going to do a plane. Try to do a low mag here. I know anything in Z, you want to be at a high mag. See what other better lighting we have going on here, because it's the focus point isn't liking the light we have going on. And this is, I know, a challenge for a lot of you guys. It's finding the best lighting for every single feature. Grab that edge there. I think last time when I was on the webinar, it wasn't liking the focus points either. So I'm going to show you, just for time's sake, I'm going to use manual points. Don't ever use manual points. It doesn't even give you flatness. It could, but it's wherever you are in Z. But just for demonstration purposes here, I'm going to do a bunch of manual points. So we get one plane over here. I'm going to make that plane a little larger. I'm going to do more inputs. We got this plane going on here. So what I'm going to do is I'm going to tolerance this plane. We're going to do flatness, 5 thou. I'm going to export this flatness. So we're all set up. Now I'm going to translate this. We're in inches. I'm going to switch over to millimeters. I'm going to translate this guy, let's say every 25 millimeters in X. I switch over to grid here because I want to do a grid system for the translate. I'm just going to say 4 copies, and then we're going to come down. Let's go 40. Let's see what we get. I commonly do this when I'm programming. I forget to go negative because it's always in relation to where I am, where my system is. So I'm going to show you guys how to correct that. So I'm going to translate positive in X because I'm going to the right on my part and on my stage. So that's fine. 25 on the grid system, 25 millimeters. We'll go 4 copies, and I need to go negative 40 millimeters down in X because we're coming towards the front of the machine. So that's negative, and it's all in relation to, in respect to the system. So we want to move this negative in Y down on the part. There we go. So now we have our 10 different sections going on here that when we rerun this part, it'll go and take all those different planes, and they all have that tolerance that we put on it. And now we can go plane more inputs, and we can click and drag, see what we can highlight, and it creates one plane across the whole 10 planes that we did. And then we can tolerance this separately to being a little more wide open tolerance in the case of our blueprint. So now we're able to do our individual sections and report those, and then as a whole, we're able to get that. So if you ever see this on your blueprint, where it's 2 flatness callouts of the same area, but it has the 10 different areas, that's what it's asking for. Sometimes you might want to talk with engineering or your customer or supplier and see how large of an area those 10 sections need to be, if they need to be really close together, or if they're depending on whatever you have going on. So it could look like this, or maybe they have just 4 sections in the 4 corners. Just make sure that you have that little bit of communication to make sure that everybody's reporting the same data, and you know top left plane to bottom right plane, which one is which on there. So using point clouds for R&D or for cloud to CAD. So if you're looking to figure out how a diameter is maybe wearing and tearing, you know, after testing. So if you're doing destructive testing or wear testing, you want to see how the brand new part compares to a part that's been used for a certain amount of time or uses. A couple of these things might help you out, and also take what I show you today, and you might not have a perfect circle or a perfect plane that you're trying to measure. It might be other kind of features. Feel free to reach out to us and say, hey, how would you use a point cloud for this type of feature? And we're also able to export the X, Y, and Z data out to an Excel sheet that if you have CMM Manager, like we have here at ATI, we're able to import that Excel file, and it reads those X, Y, Z locations and plots them on the CAD file. So we're able to get this color mapping that we see here to get profile measurements to see how the surface is actually being done. Because you might have great flatness, but your profile might be out or something might be going on with the plane and your profile's out. So this type of software is really nice to use. I know there are some CAD softwares out there that you're able to import X, Y, and Z raw data and lay it over the CAD file. So that's really nice. And you can see if you don't have CMM Manager and you have other CMM softwares at your facility, it might be worth seeing if you can do this, because you can measure it maybe quicker on the microview using Vision or Touch Probe if you have it, and then exporting it to that software. I'm going to come over to this machine part here. Actually, the first thing we're going to do is we're going to do a circle, finding out the wear and tear of a diameter. So we have our trusty old sample slide that everybody has seen and used a million different times. It's going to be a good example for us here. I'm going to come down. I'm going to do line intersection point. I'm going to do my origin X, Y, and Z just for time's sake to the intersection point and skew to the bottom line here. If you're having problems with figuring out the best system for your part, we did create a little cheat sheet of common systems that came out of one of the past webinars. Let me know and I could send you that PDF. It's kind of helpful to see, all right, my part has 2 diameters but no straight edges. I'm going to use circle, circle, and skew between those 2 circles for an origin and system. It's kind of nice to have on hand. So let's say that this diameter here, we made it brand new, and now we're doing like wear testing on it and seeing what happens when we insert a part into it, the mating part, 100 times, and we want to see what's going on with it. So if we want to see how it's wearing, and even though circularity might still be in, or if circularity is out, you want to kind of figure out what's going on with the part. So I'm going to do circle. I'm going to do an Fscan circle just to set my origin to that. So I'm going to set my origin just to that diameter, and we got our origin in the center of the circle. Now I'm going to come in, and you can use Fscan Arc, you can use more inputs and best edge, whatever you get as many points as possible around this part to see the wear and tear on it. So the first thing I'm going to do is I'm going to do circle, more inputs, best edge, and I'm going to take 1 point there. Then I'm going to come down to my inputs, and I'm going to right click on that best edge. I'm going to rotate, and I want every 1 degree, 359 copies, and I'm rotating about system 6, which is my circle. So I'm going to rotate about that system. And now I'm going to right click on circle 7 and remeasure. And so now, since I rotated it every angle 359 times, hopefully I don't crash the software with this amount of data going around it. So now I'm able to take a point exactly 1 degree around the whole diameter. So if there is any wear going on with this diameter, we're going to catch it. We also could have rotated an Fscan arc that has 100 points in each Fscan arc. So we could have placed, 1,000 points around it, whatever is helpful for you guys. Now we're almost back to our beginning. We didn't crash the software, which is nice. Now we got this points view that looks like this, but it's best fitting, since I did a circle, it's best fitting the diameter around all 360 points. But I can come down here to the point cloud icon. It's your last feature icon. Click that, and I can click that circle. And what that does is extracts all the individual points out of that circle that I did. Now we could have done the same thing and just made a point cloud around that, but I wanted to have the circle as well for the best fit circle to get a diameter and maybe some circularity. So now I'm going to come to this and I'm going to export it. You can export the point cloud as 2D machine coordinate system, which is the lower left-hand corner of your machine 0, 0. You could do 2D, so if you just need the X, Y location, or you could do 3D if you need the X, Y, and Z locations of the PCS, your part coordinate system, which my current part coordinate system is the center of this diameter. So if we want to see where all these points land on that surface in relation to the center of the circle to kind of get all the, see the farthest and closest points going on there, I'm going to do 3D PCS, even though we're probably going to have 0 for all the Z locations. I'm going to click close. So now we can come to file, export, or you could set it up automated, but manual is usually easier for any R&D that you're doing. I'm going to do point cloud .xls so we don't end up with a text file. Save. Now this could vary on how your other software wants to read the Excel sheet. I'm going to do tab new line just to do it and we can see it. But if you're having difficulty importing it into whatever software you're trying to, you might need to play around with these right here. I'm going to click OK. Now we'll go to our desktop, go to point cloud. And now we have all of our X, Y, and Z locations. So here, I have a customer that has another software that's able to take this in, lay it over the perfect CAD model, and see where the part is wearing on that diameter, what's actually physically happening to that diameter when it's being used and going through the wear test. Anytime I think about the wear test, I think about IKEA that has the cushion and just basically the hammer coming down on the cushion to see how long cushions stay. But in this case, whatever you guys are using for destructive testing, this could be useful for you. Now also, if you needed to do any other surface, so if we needed to do maybe a plane, we could do the same thing if we came over to a surface here. Anything that you're just trying to extract raw X, Y, Z location out of, you can click that point cloud and you're able to do it as well. Let's hope that the focus point works a little nicer for me on this one. I'm going to do a plane. I'm just going to do a bunch of random points around here. Something like that surface. I'm going to try axialite on there. Plane going on. I'm going to take a couple more over here. We got more inputs. few more. So we have more points going on. Must be the WebEx platform that messes with the camera. I've seen it a couple times if you get on TeamViewer. So sometimes we ask you guys to get on TeamViewer to help out. If you guys need any troubleshooting issues, we can get into your Vertex, Excel, Sol, whatever it might be, and can control your machine. I've seen TeamViewer make the camera go blank. It must be something with the video card going on. But let's move on. Let's do point cloud, and I'm going to click that plane. And so now if we open up this view here, it just takes those raw points that are going on, and we can do the same thing, export the XYZ data, lay it over a CAD model, get your profile, get your surface profile. So we found it really a lot easier to take the raw points on a microview and transfer it over to CMM Manager to get our surface profile measurements instead of punching in a bunch of basic dimensions and the profile to tolerance that in our program. It's really nice. You can automate it on there. Let's talk about max material condition and least material condition, getting some of the bonus tolerances out. So when you do true position and you do have to, and they give you the M or the L, so you get your bonus tolerance, when you export it to Excel, it gives you what the bonus tolerance is that comes out of it. So when we put in our X basic and our Y basic, our diameter, the tolerance of the diameter, it calculates the bonus tolerance for you. And it also adds the tolerance that the blueprint has, the bonus tolerance that the measurement has, and adds it together. So, you know, for this case, we'd still be in tolerance on the lower tolerance, but the bonus tolerance gives us more. Some of your SBC software, or if you're exporting to Excel, like up here, and you want to copy and paste it into your inspection sheet, it's really annoying to come over to this last column in our Excel sheet and find that bonus tolerance and put it into our sheet. So I like using the calculator function to pull that data out so it's in my one column here. So I'm able to add this to my inspection sheet to show that even if you're out of tolerance, not using the bonus tolerance, but you're in tolerance using the bonus tolerance, you have it right here nice in your Excel sheet. So it's all in that one column there. So we're going to go ahead and use the calculator function for this guy. That plane, come back to my sample slide that we have going on here. I'm going to add a recall refsys into there, set that system so we can have this fully automated. Remember, if you ever do insert here, make sure to do insert at end. So now I got this circle that is at system 4, so it's looking at my corner. I'm going to go ahead and delete this system that we have going on with the point cloud. So I want the true position of this diameter. I'm going to come to max material condition. I'm going to punch in my basic dimensions. I'm going to put in my tolerances. Remember, in the lower tolerance, you always have to put the negative sign. I got a tolerance of, let's make it tight and say 2 thou. So my true position is out of tolerance regardless of feature size, but my bonus tolerance, I am actually in tolerance. So when I export this data, we can come to export nominals, tolerances, labels. We'll do our diameter, XY, location, true position, MMC. So now we have all of our information there, but I want that max material condition to be in the one column on my Excel sheet. So I'm going to click the calculator function. I'm going to click my circle, And it gives us this whole list of data that we can pull out of that circle. So I want to go to my position, MMC, and we have the option to extract the actual zone, out of tolerance, or the bonus. So I want the bonus. When we say calculate, it comes up with our bonus tolerance that we get. So now we can export that bonus tolerance to our Excel sheet. But if you have an SBC software, or if you want your tolerance plus your bonus tolerance combined, what I like to do is go back to calculator function. I'll click my circle again. I'll click my position. I'll click my bonus, and I'll do plus. When you're using the calculator function, you need to put a 0 in front of your decimal place or it won't like it. And I'll put my true position tolerance here. And it gives us our tolerance plus bonus all in one. I'll just show you guys real quick the error. Basically just says, hey, something's going on here, highlights it. So it's a nice thing about the calculator function that it kind of helps you out of, hey, we're missing something here. Calculate that. Now we can export that data. Now if we go to File, Export, save, tab, new line, click OK. Go back to that file. So now we have our X, our Y, our diameter, our true position. So what our actual is. So that's what we would report. We get our bonus tolerance, and we get our tolerance plus bonus tolerance there. And this is nice. So if your SBC software is just looking at one column, you're able to add that to that. I had a customer last week in the training seminar ask about that if a true position is out, the normal tolerance, the SBC software is not looking at the bonus tolerance. This might be your solution here. All right, let's go to the spline trick that we have going on that I want to show you guys. I've mentioned before, I don't necessarily like splines because there's no real data or lines or features that it gives you, and you have to pull data out of it. Also, if you have any scratches on your glass, it's gonna follow that. So let's go over to our software here. I'm gonna go back to this part. I see a question popped up in the chat, and I will, once we get to the Q&A section, to give the option for everybody to get back to work or stick around, I'll cover that question that you have going on here. So when we use the spline function, if I want to just get an outline of the part, just for ease of programming, I will come bump up my lights a little bit so I'm not getting any scratches or anything on the glass that my spline might follow, because all the spline does when I click the close spline tool and I do follow closed, all this is doing is following the contrast of my part. And sometimes you'll even see that it might lose an edge if it has some weird geometry to the outside of the part. And if you have any fixturing, or if you have a threaded hole plate, that's why I bump up the lights to kind of make those features disappear. We've almost made our way around this feature here. And sometimes when it sees other lines and other edges, it'll say lost edge. But here we have a successful spline. It measured the whole outside of the part. There's no real data to it, anything going on there. If we click line, we can pull data out of the spline, which is cool because now we can grab features out of spline. But if you run your program, if you're running 100 parts, there's a huge chance that it might lose the edge and fail to measure the spline, and you're kind of working against yourself. But I use the spline to now, if I right click and I disable the spline, it won't measure the spline, but I know where my features are, that if I right click in the schematic window, I'm able to move right where those features are, or at least close by to where they are. So quicker programming, less time using your joystick or the stage control, and maybe moving past your part, whatever it might be, quicker programming going on here. So you can do your whole program. You can disable the spline so you have an outline of your part for the whole, like every time you open up the program, or once you're done doing your whole program, you can right click and delete your spline so it's not even there anymore, and you just have the program you need on there. So it's a little trick to use the spline. Just remember, bump up your lights so you avoid any scratches on the glass. A couple things, one more topic I want to get through in the last 5 minutes, and I want to respect your guys' time. If we go a little long, I will record it, and if there's anything that you miss, you'll be able to get it off the recording on there. So max and min data. So point cloud, we did that plane on that one surface. We were able to extract that point cloud to Excel sheet, but also if you measure a plane, and then if you click point and click that point cloud or click that plane, whichever one you want, we can actually ask for the maximum in Z or minimum in Z. So if there is, you want to see the highest point on the plane or you want to see the lowest point on your plane, you're able to pull that data out and export those specific locations on there. So again, you measure your plane, you click point, so you're measuring a new point, and if you just click your point, this box comes up here, and you're able to do that. And you also can do it for lines, anything like that. I believe in a previous webinar, we talked about, finding the largest flash going on there. So remember that this is an option that you're able to pull max and minimum features out of planes. What I do want to hit is I got this circuit board over here with all these diameters, and I want to show you another calculator function that I like using. I'm going to measure a bunch of circles. Try using the profile this time. Profile, so we're getting all these diameters. Do 5 for now, and say we went and got all of our diameters. Now we want the maximum diameter size of all these diameters. We want the minimum, and we also want the average. So I'm going to click the calculator function, and you got all these options over here where I'm going to do average. I'm going to click my diameter. Here's a little trick to do calculator function faster, is I'll do diameter actual. I'll click my next one, diameter actual, and go through all of them. So I get all my features. And then I'll put a parenthesis on the end. When you hit calculate, it's going to yell at you because it needs commas between each of them. But it was easier to have my mouse just click all the diameters first, and now go back and put my space, comma. Now we got our average between these diameters. But instead of having to go back and click each one of these, if you're getting average, max, and min, highlight everything up until the first parenthesis, copy it. So I just hit Control C to copy it, hit OK. Now I'm going to hit calculator function again. I'm going to say I want the max diameter, and I'll hit Control V just to paste what diameters I'm looking at. Hit calculate, hit OK, and I'll hit calculator function one more time, and I'll hit min, paste my diameters, calculate. Now I got my minimum. So now you can see in our summary tab up here that our Average diameter size through all of them is 0.46. Our largest is 0.48, and our minimum is 0.42. So this might be helpful if you need to report average, max, and min for diameters to see how your process is doing across the same board of all these diameters on here. Couple slides here. One thing that I want to get before people leave is I want you guys to have a chance to win a seat for the Best of ATI Training Seminar that I was talking about happening in October. It's going to be in the Rosemont, Illinois area, which is right next to O'Hare. 3 ways to enter. And I just realized that my numbering on my slide is all off. But go, and if you're on LinkedIn, follow Assurance Technologies on LinkedIn. If you already follow us, review and recommend Assurance Technologies, or you can post or tag about us here, about the webinar today, about calibration services, maybe a service guy came and did calibration on site, any support that Dan or I gave you. We would love to hear and have you guys share about your experiences with ATI. So I'll be looking at these. If I'm by next Monday, I'll see who's entered to win a seat for the ATI Training Seminar. And next webinar in August, I'll announce the winner, and I'll also send you an email. So go ahead and follow us on LinkedIn, review or recommend, or post and tag. Doing all 3 is amazing, but you just have to do one of them to enter on there. So right there, 1 minute longer than I like to promise. I want to keep you guys around just for an hour to respect your guys' time and your inspection time and all that. But if you guys have any questions, pop them into the chat box. I know I threw a lot of information at you guys, but feel free to pop any questions. And if I'm able to answer them live with a sample part that I have, awesome. If not, as always, Dan and I will follow up with you afterwards. It looks like Dan was able to answer Rick's question in the chat. Yeah, if there's anything around, if there's any questions, feel free to pop them in the chat box. If not, thank you guys for attending this webinar. I feel like I tried to put too much information into this one and talk too quick. But any other suggestions for next month's webinar, we are all ears and would love your input and your sample parts to use for a little variety of parts during the webinar. So we'll stay on here for a few more minutes. If we don't see any other questions, look out for my follow-up email for the survey and to register for the August webinar. So thank you guys. Thanks for attending, and we will see you in the next webinar.